So, we're in Tonga, which is an island near Fiji, and it's one of the only islands in the world where you can swim with humpback whales. Below me is two adult humpback whales, and they're about 12 meters long. That's longer than a double-decker bus. Let's go and say hello.
Now these whales are absolutely huge, and you don't realise how massive they are until you're swimming right next to one. This is my humpback whale selfie. Now whales are shaped like a long cylinder, and we're going to estimate the volume of a whale by calculating the volume of the cylinder that the whale would fit in. Now one of the whales I was just swimming with would fit inside this cylinder, and this cylinder has a radius of 1.15 meters and is 12 meters long. And remember, that's longer than a double-decker bus. Now we've already learnt in another lesson that a cylinder is a prism because it has the same cross-sectional area. And to calculate the volume of any prism, we need to use this formula. The volume of a prism equals the cross-sectional area multiplied by the length. And you're given this formula on your formula sheet, so you don't need to remember it for your exam. Now the first thing that we're going to do is calculate the cross-sectional area. Now this area here is the cross-sectional area, because if you were to cut a slice off the prism like this, then this area here will still be exactly the same. So this is the cross-sectional area. So the first thing that we need to do is calculate the cross-sectional area, which is the area of this circle. Now remember, the formula to find the area of a circle equals pi r squared. So we need to rewrite this formula substituting the value of r, which is the radius. Now we're told that the radius of this cylinder equals 1.15 meters. So rewriting this formula, this equals pi multiplied by 1.15 squared. Now I do this on a calculator and it equals 4.15 to 2 decimal places. So the cross-sectional area of this prism is 4.15 meters squared. Now that we've calculated the cross-sectional area of the prism, we can now find the volume of the prism. So to find the volume of the prism, we need to do the cross-sectional area, which we've just worked out, and that's 4.15, multiplied by the length. And the length of this cylinder is 12 meters. So we're multiplying by 12. Now I do this calculation on a calculator. Now when we're entering this calculation into the calculator, we don't want to use 4.15 because this number here is a rounded number. So we want to use the full calculator answer that we still have on the calculator from earlier. So to multiply the full calculator answer by 12, we just need to multiply this answer on the calculator by 12. Pressing equals, this gives us a long decimal answer. Now we need to round this answer to 2 decimal places for our final answer. So the volume of the cylinder is 49.86 to 2 decimal places. Now we need to put some units on the end of this answer. Now all of the distances was measured in meters, so the units of volume in this question is meters cubed. And this is now my final answer. In more difficult questions, they will give you the measurements in different units to try and trick you. You can see here that the radius of the cylinder is measured in centimeters, but the length of the cylinder is measured in meters. Now we cannot use measurements that are in different units when calculating the volume of a cylinder or when calculating the volume of any prism. So before we start this question, we would either need to change 1.5 meters into centimeters or change 25 centimeters into meters. Now I think it's easier to change 1.5 meters into centimeters, and 1.5 meters is 150 centimeters. Now that all of the measurements are in the same units, we can now complete this question. Now some teachers and textbooks use this formula to calculate the volume of a cylinder, but you're not given this formula on your formula sheet. So I think it's much easier to use the volume of a prism formula to calculate the volume of a cylinder, because you are given this formula on your formula sheet. And actually these two formulas are exactly the same as each other, because the cross-sectional area of a cylinder is just the area of a circle, which is where the pi r squared part comes from. And the length of the prism is exactly the same as the height of the cylinder, which is where h has come from. So really, these formulas are exactly the same as each other.